Problem 1. What is the value of 9,901 times 101 minus 99 times 10,101? We can do this problem by noticing that we can rewrite this expression as 10,000 minus 99 times 101, then minus 99 times 10,000 plus 101. Because when we expand this, we're going to get 10,000 times 10. Oh, sorry. So, actually this here is 101. So, when we expand, we get 10,000 times 101 minus 99 times 101 minus 99 times 10,000 minus 99 times 101. And if we look at this term and this term, they're going to simplify to 2 times 10,000. And if we look at this term and this term, they're going to simplify to 2 times 99 times 101, which is equal to 2 times 10,000 minus, and using difference of squares, this is equal to 100 plus 1 times 100 minus 1. So we can write that as 2 times 10,000 minus 2 times 10,000 minus 1. So our final answer is going to be 2, or A. Problem 2. A model used to estimate the time it will take to hike to the top of the mountain on a trail is of the form T equals AL plus BG, where A and B are constants, T is the time in minutes, L is the length of the trail in miles, and G is the altitude gain in feet. The model estimates that it will take 69 minutes to hike to the top if a trail is 1.5 miles long and ascends 800 feet, as well as if a trail is 1.2 miles long and ascends 1,100 feet. How many minutes does the model estimate it will take to hike to the top if the trail is 4.2 miles long and ascends 4,000 feet? Alright, so using the information from the problem, we already have two equations. We know that it takes 69 minutes if the trail is 1.5 miles long and 800 feet. Similarly, we know that it will take also 69 minutes if the trail is 1.2 miles long and ascends 1,100 feet. And what we want to find is how long is it going to take to hike a trail that is 4.2 miles long and ascends 4,000 feet. So looking at these two equations here, we can immediately see, since 69 is in both of them, subtracting will cancel out the left side. So we're going to get 0.3a minus 300b equals 0. So 0.3a equals 300b, which means that 3a equals 3,000b and a equals 1,000b, okay? All right. So now plugging this equation, a equals 1,000b, back into one of our equations here, we have 69 equals 1,500b plus 800b. So our answer is going to be, well, we have b equals 69 over 2300. So the answer is 4.3 times a, which is 1,000b, plus 4,000 times b. And if we simplify this, you get 42 times 3 plus 120, which equals 246. So the answer is B. Problem 3. What is the sum of the digits of the smallest prime that can be written as a sum of 5 distinct primes? So since we're summing 5 distinct primes, if we had, for example, if we had 2 as one of our primes, we know 2 is the only even prime, so all the other primes have to be odd. So if 2 was one of our primes, and then we added 4 more odd primes, well, 4 times an odd number is going to be even. And 2 plus an even number is going to be even. However, since this sum has to be a prime and there are no other even primes other than 2, we know that we can't have 2 be one of these primes that we're summing. So we can list the smallest 5 primes that don't include 2, so that's 3, 5, 7, 11, and 13. And if you sum them, you get 15 plus 24, which is 39. And 39 is not prime. So we want to find the next smallest sum of 5 distinct primes. Well, to do that, we can simply replace 13 with 17. That would increase our sum by 4 to get 43. And so our final answer is 4 plus 3, which equals 7, or B. Problem 4. The number 2024 is written as a sum of not necessarily distinct 2-digit numbers. What is the least number of 2-digit numbers needed to write this sum? So we know that the largest 2-digit number is 99. So we can see how many times 99 fits into the 2024. So we see that 21 times 99 is less than 2024 if we check our work. Okay, actually it's not, so we did something wrong. But if we try the long division again, we should get a 2 here, so 198, 34. So we know that 99 goes into 2024 20 times. So we can write 2024 equals 99 times 20 plus 34. Sorry, plus 44. So that means that the number of 2-digit numbers that we're using to write this sum is 20 plus 1, which is 21, our final answer. So we get B. Problem 5. What is the least value of n such that n factorial is a multiple of 2024? So as a reminder, n factorial basically means that you multiply all the numbers from 1 to n. So for example, 5 factorial would equal 5 times 4 times 3 times 2 times 1. So since we're thinking about 2024, to learn more about it, we can find the prime factorization. So 2024, we know is 4 times 506, which is 8 times 253, which is 11 times 23. So we see this 23, and if we think about 23 factorial, we know that it has a 23 as one of its factors. We know that it has an 11 as one of its factors. And it definitely has an 8 as one of its factors. And we know for n factorial, for any n smaller than 23, it's not going to have 23 as a factor. So that means that 23 factorial is the best we can do. So n equals 23. Problem 6. What is the minimum number of successive swaps of adjacent letters in the string A, B, C, D, E, F that are needed to change the string to F, E, D, C, B, A? For example, 3 swaps are required to change ABC to CBA. One such sequence of swaps is ABC to BAC, 2 BCA to CBA. So if we think about the string A, B, C, D, E, F, eventually to get F, E, D, C, B, A, we want to get F all the way to this side. So maybe we can just start by just getting F to the opposite side and seeing what happens from there. So in order to do that, we can first swap E with F, like this. And then we can swap D with F. So we'll get this. And then we'll swap C with F, right? So what we're doing is this, this, right? And now we're going to swap C with F. And then we're going to swap B with F. And finally, we'll swap A with F. And so finally, we've gotten F in the right position, and that took 1, 2, 3, 4, 5 steps. So we can essentially do the same thing with E. We know that we want E to get right here. And we know that's going to take 1, 2, 3, 4 swaps. So far we've taken 9 steps to essentially get F and E in the right spot. And we can do the same exact thing with D, C, B, and A. So our final answer is going to be 5 plus 4 plus 3 plus 2 plus 1 plus 0, which is equal to 15. So our answer is D. Now you might ask, how do we know that we can't get a smaller number of swaps? And I'm not really going to explain like a proof for this, but I would just say that this kind of method of first getting F to the right position and then getting E to the right position and then D and then C and then B and then A, we know that that takes this amount of steps. And we can try the exact same method on A, B, and C, right? So to get C to this spot here, it's going to take 2 swaps. Then to get B in the right spot, it's going to take 1 swap. And for A, it's going to take 0 swaps. And we get an answer of 3 using the method we used to get 15. And we know the right answer for a string of length 3 is 3, right? So we can kind of see that our method works for like a smaller example. So it would kind of make sense that our method would work for a bigger example like a string of length 6. Problem 7. The product of 3 integers is 60. What is the least possible positive sum of the 3 integers? So we can factorize 60, and what we'll get is 2 to the power of 2 times 3 times 5. So I guess when I read this problem the first time, the first thing that stands out to me is the fact that they say a positive sum. So that kind of implies that one of the numbers could be negative. So if we think about why, we realize like we could either factor 60 as a positive number times a positive number times a positive number, right, for 3 integers, or we could do as a negative times a negative times a positive. In order to have these 3 numbers here have the least possible sum, we basically want the absolute value of these 2 numbers, their sum, to be almost as big as the absolute value of this number, but not quite as big. So I'll kind of make that more clear with an example. So if we say, for example, if we say the 3 factors are -2, -2, and 15, right? That would give a sum of 11. But that's not a very good answer, because if we made these two numbers bigger in magnitude, but not as big as this number, we could get a smaller and smaller sum, and that's what we want for this problem. So how is that possible? Well, we know we can write 60 as 1 and 60, as 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And then after that, we'll get 10 and 6, but that's the same thing as what we've already listed. So if we consider this case 6 and 10, this is kind of the case where like the larger of the two factors is the smallest, right? And so if we write 6 as 1 times 6, then we'll have 60 equals 1 times 6 times 10. So if we make these two negative and these two positive, we'll get a sum of 3, and that's pretty good. Notice that we can't really find like a triplet of numbers such that two of them are like, like 1 and 6, they sum to 7. That's so close to 10, but it's not quite 10, right? And that's why we get such a small sum. So it turns out that the triplet 1, 6, 10 is actually the best we can do. So our final answer is 3, or B. Problem 8. Amy, Bumani, Charlie, and Daria work in a chocolate factory. On Monday, Amy, Bumani, and Charlie started working at 1 p.m. and were able to pack 4, 3, and 3 packages, respectively, every 3 minutes. At some later time, Daria joined the group, and Daria was able to pack 5 packages every 4 minutes. Together, they finished packaging 450 packages at exactly 2:45 p.m. At what time did Daria join the group? Okay, so we know that Amy, we'll use A, B, and C. Amy, Bumani, and Charlie. They've been working since 1 p.m. and they stop at 2:45, right? So that means they've been working for 105 minutes. And we know that they're able to package 4, 3, and 3 packages every 3 minutes. So 105 divided by 3 gives us 35. So basically we have 35 intervals in which they're packaging this amount of packages, right? So that means that from 1 p.m. to 2:45 p.m., A, B, and C have packaged 4 plus 3 plus 3 times 35 packages, which equals 350 packages. We know that A, B, C, and D packaged 450 total altogether. So that means that Daria must have packaged 100 packages. Now we know that Daria was able to pack 5 packages every 4 minutes. So that means that she had 20 intervals in which for each interval she packaged 5 packages, right? So 20 intervals, and each interval lasts 4 minutes. So that means that Daria was working for 80 minutes total. So we know that she worked for 80 minutes and she finished at 2:45 p.m. So we can just go backwards from 2:45 p.m., right? 2:45, you go back 80 minutes. Well, that's like going back an hour and 20 minutes. So we would get to 1:25 p.m. So our final answer is A. In how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people so that each team has 2 juniors and 2 seniors? So we have our 3 teams here. We're going to have 2 juniors and 2 juniors in each team. So we can kind of think about it like we're going to go to the first group and we're going to say, okay, out of the 6 juniors, we're going to pick 2 of them. The order doesn't matter, right? It doesn't matter if we pick Sarah and then Sally or Sally and then Sarah. It really doesn't matter. Likewise, we're going to pick the 6 seniors, if I said juniors before, right? And then now we have the first group kind of completed. we move on to the second group. And since picking each group, since those are independent events, we're going to multiply. So for the second group, we have 4 juniors left, and we can pick 2 of them. Likewise, 4 seniors left, and we can pick 2 of them. And then for the last team, we don't really need to do anything else because whoever is left goes into the third team, right? But as we were multiplying, we were assuming that if we place like the order, we're assuming that the order of the groups matters. Like we're saying, oh, like first I'm going to put the people in this group, and then I'm going to fill this group, and then I'm going to fill this group. But in reality, it doesn't matter what order we fill the groups in because all it's asking for is 3 disjoint teams. So in the end, we're going to have to divide by 3 factorial because that's the number of ways that we can arrange the same 3 groups. So evaluating this, we know that 6 choose 2 is 6 over 4 factorial times 2 factorial, which is 15. So we're going to get 15 times 15. We know that 4 choose 2 is equal to 6. So multiply by 36, I'm going to divide by 6. So our final answer is going to be 135 times 10, so 1,350. So our final answer is B. Thank you guys for watching this video. If you found it helpful, please leave a comment, leave a like, or subscribe. And if you have any questions, please feel free to comment, and I'll try to get back to you.